afternoon. Hope you all had a good lunch. We are now going to commence with the next presentation by Mr. Fabrice M.mp4. Allow me to please introduce him. Fabrice is the manager of FMA RMS, a small dedicated security consulting firm based in Singapore. Developer by trade for many years, he has been involved in the information security field for over 7 years. His interests are in secure programming, cryptography, open source, and firewalling techniques. For the last few years, he has been breaking mostly bank and telecom web applications in the Asia-Pacific region, as well as performing penetration tests for them. Originally from France, Fabrice has been staying in Singapore for the last 6 years. And today he will be presenting to us Application Intrusion Prevention Systems, a new approach to protecting your data. Ladies and gentlemen, join me in welcoming Fabrice M.mp4.
Thank you. So the whole goal today basically is to present some new technologies that are not ready yet, will be ready soon. There is a big gap on the market right now in terms of application security. We'll see why it's important and why there is a gap. And the whole goal is to present technology that will effectively stop application attacks when properly implemented. Right now, people tend to forget that application security is extremely important. When you look at the amount of money spent on each layer, you quickly realize that application is the one on which you spend the least. Having said that, it's not quite true. You pay your applications millions of dollars, and yet you don't secure them, you don't care. You just put them there, get some crappy implementers to put it in place for you, and then it just doesn't work. So $1 million application that doesn't work is a bit expensive. And when it works, it won't be secure because you didn't audit it and things like this. Why do we want to hack web applications? It's very simple, because we can. It's as simple as this. It's not because you are who you are, we don't care. We do it because it's possible to be done, full stop. And remember, applications are extremely important. If you have applications in the first place, it's because you need to take care of the data. That's why you have computers in the first place too. Network is totally irrelevant. You don't need a network to run half of the applications you're running. It's just today they are networked. So today we have more vulnerabilities due to that. Why do we want to hack the web applications? It's also because it's a lot easier to hack than through the network. I mean, a normal network-based attack. On a normal network-based attack, you would have to penetrate the firewall, penetrate the systems, escalate your privilege, find a way to perform your fraud, perform it, and hope for the best. And if you're not caught by then you're very good. Whereas on the application, we don't need to do all this. We talk to the application directly. We pervert it to do exactly what we want, as opposed to what it wants. And by brutalizing it a little bit, we just get what we want. Remember, attacking applications is generally simple, provided you know how to program and things like this. If you do, then it's very straightforward. The main problem in application right now is that there is not enough knowledge, basically. Gartner found out that there's about 32% of Java developers who have a genuine knowledge of the language. 32% worldwide. So for all the rest, sorry for you. But don't laugh, those are the guys who write your applications. Those who are good are not working around here. I don't know where they work, I haven't seen many yet. I would say that it's less than 32 actually. And when they say 32, it's just genuine knowledge. It doesn't mean they know anything about security. It means the guy can code in the first place. So basically, yeah, programmers are just under-skilled. Real programmers don't exist anymore. They don't even know how memory functions. Remember, you have control over your network because it's building blocks, a firewall here, a hub there, a switch there. It's all generic appliances, but it's not the case with applications. Applications are growing massive and complex, and the more complex it is, the more flaws you're going to find. Of course, why we want to hack web application is, of course, to make money out of it. Why not? That's always been the holy grail of any attack. Fraud or laundering money, stealing, things like this. I presented on hacking internet banking last year. A quick recap of what we said last year. This is typically what you find on a bank application. This is no bullshit. This is based on 17 or more applications we've done last year. I was lazy to update the statistics for this year. It takes quite a bit of time to update the statistics. So basically all your horror become true. Whatever you thought that the bank is good at protecting your money and everything, it's exactly the opposite that is happening. It is, they are the most trivial systems to attack, and the most trivial system to steal money from, of course, because they are dealing with money in the first place. A web application that takes care of, for example, booking a conference room, you won't be able to steal no money from it. It doesn't handle money in the first place. So you need to find a good target application that does a function that you could possibly pervert, and then you pervert that functionality to act the way it should for you and not for the owner. So yeah, we steal money, we look at your credit records, everything. It doesn't mean all the applications have all those bugs, no, but I have some statistics broken down, and the interesting one is, for example, every single application you could steal money from. So if you look at stolen money, it's this one here. It's only 9%, but 9% globally. And still, in each application you had at least one such bug. So it's scary. It means every single bank could have been defrauded. For the stealing personal information, it's the same. It's a privacy matter. You can sue the bank for leaking your records. And it's the same. Every single application, where is it? Every single application had such a problem. So this is just to cool you down and take me seriously. You know? It always works. So now, there's two ways to go about it security-wise. You can prevent the attack in the first place, which is not happening, and you can detect. This is what IDS do. So why do we want to bother with detection? It's very simple. If the application was so good, we wouldn't care. The only reason why we still want to detect, even if the application is super secure, it cannot be hacked, is because we want to find out who is trying in the first place. I don't want to have some kiddies playing against my application trying to break it, even though it's not breakable, imagine. I just want to stop them from doing it in the first place. But before you can take action, you need to have detection. If you don't know the guy is attacking you, how can you stop him? Why do we want to bother with detecting and taking action? It's because we want to sue people, of course, why not? You want to stop him, a good way to stop him is send him a legal letter and he will stop. Or send the police after him, he will also stop. We can't do this with network attacks because of the complexity or the simplicity of the protocols, in which case it's very hard to track down who did the attack. And of course the proof will not be held in court. Whereas for application it's trivial. Most of the application attack you need to be already logged on the application. So we already know who you are. So as soon as we detect the attack, we can already send the police on its way. So for now, some applications, very few, I've seen one so far that almost had no flaw. Very few stop attacks, as in prevent us from attacking in the first place. But then they don't stop us from trying. This is the whole point of what we want to do. So what's the problem with modern IDS technology? You know, everybody working in a large company has an IDS running somewhere. They have no idea what it does, but I will explain you. Basically what it does is that it looks at symptoms of successful attacks, or attacks for those lousy IDS. A good IDS will look at successful attacks. A bad IDS will look at any kind of attack. It looks at the symptoms. It doesn't look at the attack. It knows nothing about attacks. So some symptoms of a network attack is, for example, if you have a guy executing a remote shell on your machine from another country. That's obviously an attack. And things like this. For application, it's a lot harder. How do you define an intrusion? How do you know whether I transferred money from my account to somebody else's account, or if I used your accounts as the source? The IDS wouldn't know. So right now, modern IDS can potentially detect some of those classic ones: SQL injection, cross-site scripting, all sorts of overflow and brute forces. Those are really basic attacks. Those attacks are useless. Don't get me wrong, I mean, they can get you some stuff, but you're not going to steal money from the bank, so I'm not interested. I'm interested by real results. And real results are generally achieved by logic flows. Like I say, you just use a functionality that already exists, like fund transfer or things like this, and you just pivot it to transfer to you instead of from you. So what do we propose? Very simple. We propose two similar technology, but a little bit more geared to one application. We propose a network-based application intrusion detection or prevention system, and a host-based one, as in an application-based one, based on a framework itself. So if you were to do a network-based ideas for application, it would have to be generic. It wouldn't know anything about your application. It would know only about the communication protocols, and therefore, as such, would be able only to catch basic attacks, those classic attacks, those generic attacks. Like I say, the interesting thing with applications is that attacks are not generic. Otherwise, you would see a lot more interesting talks on it, giving you an exact way of hacking it that always work. But you can't do this because it's very specific to each application. So that's why we also propose an application-based one, a host-based one, which is basically a framework that developers will use and put constraints into it that the framework will later check. So what would be a network intrusion detection or prevention system? It would typically be a proxy, as simple as this. Of course, it would have to be better than the regular proxy that exists today. The proxies that exist today, just proxy. They take the information from the left, put it on the right, and vice versa. So it's not much use. We want to do something like this, but we want to validate every single step while we do it. So the advantage of a network IDS is that it protects even your legacy application. It doesn't care what application is behind. So the advantage is all of you already have applications deployed. A network application IDS at least would protect those, or at least would try. A host IDS, on the other hand, would be a lot more comprehensive and a lot more accurate. Problem is, it can only protect applications that were written with it. So what's the main goal of this talk? It's very simple. The main goal, you will see, I will go at great lengths at it, is really to differentiate between an attack and anomalies. Okay, this is the holy grail of every IDS. You want to avoid what we call false positive and false negative. In other words, you want to avoid a crying wolf, and you want to avoid having attacks that are not detected. So how do we do this? Basically, we will look at exactly how attackers, whatever hat they wear, how do they attack applications, and see, can this be considered purely an attack, or could this be considered an attack and an anomaly, in which case we can't take any action on it. So first things first, sorry, I'm a bit sick. First things first, we'll look at the typical dialogues or widgets that you have in web applications. Typical web applications always have the same widgets, fields, drop-down list, menus, everything, you name it. So there is basically two categories. You have those free-form one, which is, for example, please enter your name. I don't know your name in advance, so I cannot restrict you on it. And you have some that give you a choice, a limited choice. I already know in advance that you will choose one of those. Those are radio buttons or drop-down list and everything. Okay, so for example, if we take this mini bank mini application just to play with banking, this is free-form, the amount. I don't know in advance how much you want to transfer. However, I know you will transfer from this account or this account. Why is this important? Is because later I want to verify that you didn't mess with this, because you're not supposed to mess with this. So supposedly, restricted parameter cannot be changed. In other words, if you were a normal user and you just use a browser, you are limited by this choice and this choice only. The fact is, of course, an attacker can modify those. An attacker will not use the browser just like this. It will use what we call an interactive proxy, modify the value on the fly, and send you basically, if we look again at this one, it will change the to account or the from account to whatever account he wants. So of course, if the guy does this, we know he had an agenda, we know it's an attack, it's obvious. A normal user couldn't do it even by mistake. It's not possible. He must install some proxies, and he must mess around. If you mess around, we can catch you and we'll take action. So tampering detection, as far as the network IDS is concerned, can be done, but it's not trivial. When the application sends the form to the browser, we can parse it and record whichever fields are supposed to not be modified. And then when the response comes back from the user, we can analyze and verify if the guy messed with it or not in a limited manner. So what's the problem with this? The problem is, what about bad HTML? About 90% of the websites out there don't know how to use HTML. It's not valid HTML, so it's hard to parse. Your browsers are very nice. They let you display crappy HTML. It shouldn't. I tell you, if it didn't, then people would use proper HTML. It would just work. What about when people are not using HTML forms, they are using what we call remoting, which is basically whichever remoting protocol you may want, XML-RPC, SOAP, AJAX, JSON RPC, all those, like in Gmail, for example. Well, those, since there is no form going to the clients, there's nothing I can record, so there's nothing I can check on the way back. It can be implemented on a framework itself, so that's a lot more accurate, because the form itself, or the interaction itself is built by the framework, by this guy. The application core asks the HIDS to actually build a form for you. Well, at the building time, you can record and get all the constraints. So on this way back, when you come back, you can verify the integrity of all those. So now, what about detecting behaviors? Like I said, the whole goal of this talk will be detecting behaviors. We know the behaviors of attacker, because we're attackers ourselves. So we'll list those that are obviously attacked that we can catch, and we'll build this into the framework. So some mistakes are definitely not mistakes. For example, if in less than a minute you already failed your password 5 times, either you're an idiot and you don't remember your password, or you're attacking. And in 1 minute, it means you type it really, really fast. You're really stubborn. A real user who forgot his password will fail it 3 times. Sorry, he will fail it 2 times, and then he will think twice. Should I type it a 3rd time or not? So there will be a pause, and it will be more than a minute. It's the same if you're trying to do SQL injections or cross-site scripting in a very blatant manner on a field that obviously doesn't contain such characters, then we can detect it very easily. Same for buffer overflow. Who knows family names that are more than 200 characters? You're obviously attacking me. And I don't have a sense of humor. So mistakes that are not mistakes, it's the same when you ignore the flow of the application on normal, for example, e-business application, you have to check out first, then confirm, and enter your credit card and everything. If you go directly to the thanks for purchasing this item, you're cheating. You didn't follow my links, you went underneath. If you go underneath, I see you doing it, I catch you and I stop you. A very simple one, but I like very much. I hate filling forms, like all of you. And when you have forms with 50 fields and you fill it under a minute, either you're the fastest guy that type that I've ever seen, or you're cheating. You're obviously using a program to do it, as in you're attacking. Same, all of you know what's a CAPTCHA. CAPTCHA is when you subscribe, sometimes they ask you to write down those letters that you see on the image. If you fail it 5 times in a row, it's either you are totally blind, in which case the organization have to do something for you, or not, it depends if they support blind users, or you're obviously attacking and you don't know how to attack. So you will see this NIPS and HIDS love people who don't know how to attack in the first place, because they're easier to catch. And those who know how to attack will be caught using some more difficult ones. But at least all those easy ones will be out of the way. So on a network-based one, we could implement some more. I mean, mostly only this you can put on the network one. It's very limited because it has to be generic. So we could check, of course, if you're trying to put some scripting inside there. If you do, we could catch you. The problem is that there will be a lot of false positives. What if it's a forum and it's a technical forum and I have to write those to show you, for example? Then you would fail. SQL injection is the same problem, and buffer overflow is the same problem. We could basically try to catch you, but it would have to be really adapted to your environment. And we all know what happens with generic ideas that you adapt to your environment. You never adapt it properly, and then there's a lot of false alarms. The security admin get tired of having his pager page all the time, so you just put it aside. So it means you're getting attacked and you don't even know anymore. So all of them have a lot of false positives and a lot of false negatives. I don't like network ideas in the first place. That is pretty obvious. They are trivial to bypass, even those for purely network attacks. So of course, having said that, it means we'll mostly focus on the application-based one, on the framework itself. So the main goal, like I said, of detecting this attack is so that we can take action. I don't want you, trying too hard. Let's say somebody is trying to rob your house and your house is a fortress. You know they won't manage, but then you don't want him banging on the door the whole night. Neither do I on the application. So, and also I want to know who performed what and when. This is very important. If there's a fraud later or things like this, I want some forensics expert to be able to do their work, which right now they can't. Right now your application has 0 log or 10 million log, in which case it's the same. We can't parse them. And of course, because I detect now, we'll be able to prevent. As soon as it triggers, we stop the guy exactly where he is, and we take action. So what kind of action can we take? Very simple, you name it. It could be done in a plugin form. So of course, such a framework could implement some basic ones, like email the sysadmin, send SMS, put a light that rotates and everything. It's very fun. We used to do this in 1999, having a light like this that rotates. After a while, there were so many attacks that it grew on our nerves, so we took it out. Especially when people are not succeeding in the attack. You could do pretty much anything you want. My favorite basically would be to redirect the guy to some other site. Like this, the guy wouldn't even find out it's been redirected and he would continue attacking. A funny one would be to redirect them on the American government, for example. That would get them angry a bit. But that wouldn't be really friendly. If you're a big corporation, you couldn't do that. But at least you could redirect them to a honeynet or things like this. So now, how do we plan to do this, host-based intrusion prevention system for application? We'll do it in the shape of a framework. All those techniques that we'll explain later, you can already take them one by one and integrate them in your existing application. But it's a pain. What I propose is that we write a framework, a generic application security framework that new applications could use when they get written, and that would protect them automatically as much as possible. It's always as much as possible, unfortunately. So this is how it goes. What we propose is this, the whole underneath. So how does it work? It's very simple. When you build a form with constraints to get some input from the user, you go through the HITBS. It will build a form for you with constraints. It will record those constraints. It would record those constraints and send the form to the client. Now, when the forms comes back, when the data of the form come back, remember we recorded all the constraints. We are the one who built that form. We as the HITBS build the form, so we know exactly what's in it. We know the constraints and everything. So now we can check, did you mess with it? Did you modify stuff that is not supposed to be modified? Did you try to attack me with some classic attacks? I will list them later. Do you not follow the instructions? I told you the name is maximum 20 characters. Why are you trying to put more? I will verify this here. And of course, I will verify everything else here. Is this your account in the first place? Are you authorized to do it? Every miscellaneous validation will be done there. So anytime there is a problem spotted here, it will be sent to the scoring system. What is the scoring system? It's very simple. We just look at, we give you an attacker score. The higher the score, the more nasty you are. And then we can put a threshold. Let's say, imagine it's a scale on 1 to 10. If you go let's say above 5, we can say, okay, I alert the sysadmin. If you go above 7, I could call the police and things like this. Voila, so build a form with constraints. Typically the framework will mark for you hidden fields that hidden. It will remember what's the maximum value of fields. It will auto-generate the JavaScript for you, the client-side JavaScript. So that's interesting, at least you will have valid JavaScript after this. I'm tired of seeing JavaScript that doesn't even run properly. At least if the framework generates it for you, it will work. That'll be a good change. And of course, this JavaScript will be one more layer. We can detect later if you bypass it. If you bypass it, again, you're an attacker, and we will mark you as such. The whole goal of remembering those constraints is so that we can check them on their way back. Now, when they come back, we will verify that fields that are not supposed to be modified are not modified. So, for those of you who believe hidden fields are really hidden, they're not. For those who believe that you can't modify them, you can, if you want to. But then if you do so, you're attacking us, and if we can detect it, so we'll stop you. Now the fun part, the attacking behavior detection. All those little attacks, or big attacks, it depends, do you steal money with it or not. All those are typical that every application tester or every hacker would try on your application. But because they are so typical, of course, we can put them in the framework and you won't be able to do it anymore. Example of an attack behavior. You keep on failing everything you're doing. A normal user is not that stupid. And if he is, well, you give him a bad score and then he will call the bank and the bank will talk to him. You know. SQL injection is the same. You're trying to attack us with very basic attack. SQL injection is very basic attack. It's boring. Okay, you can do whatever you want at the end of the day on the database system if you succeed. And then what? Can you steal money with an SQL injection? No. So you don't interest me with it. Of course, it can be very interesting on a forum. Forum is purely based on SQL databases. On a news site as well, you could change the news and put some false news, which is the best way for a news corporation to get sued. Buffer overflow as well would be trivial to detect. Missing cookies, one of my favorites. Cookies are put by default on your browser, and we can force you to accept them. And so you will accept them or not use the application. But then if all of a sudden they're missing, it means the guy is trying to attack by hand and forgot to put the cookie. I'm sorry, when you attack and you forget to attack properly, then of course we'll catch you. Missing referrer is the same. It's on the browser always puts the referrer. It's only attacker who don't put it. Some software out there remove it, but then I will prevent you from using them. I will tell you as one of the conditions to use my application, you cannot use such a proxy that removes the referrer. Missing parameter is the same. Imagine a form with 5 fields. If the form comes back to me with only 4 fields, it means you don't know how to attack. It means you forgot 1 field. The browser doesn't forget fields. It's the same if you are attacking and all of a sudden the user agent is modified. Let's say you logged on using Internet Explorer, and then the next request I get from you is using Mozilla. Obviously, it wasn't Mozilla. You cannot transfer a session just like this. Obviously, you used the proxy, modified something, and modified it wrongly. Wrong payload encoding is my favorite. There's so many encodings in HTTP that when attacker attacks, sometimes, even myself, sometimes make mistake. We encode wrongly. Again, if you do, it means you don't know how to attack, or that you go too fast, and we'll catch you. Wrong header encoding is exactly the same, but on the header. Suspect URL are a classic. Who didn't try this on an application? One of the first things you try is to escape from the application and get, let's say, the password file when you go etc password, for example. If you do this, we'll detect it automatically. Which user does this? If he does, it's not a user, it's an attacker. Those files are typical configuration file. This is on .NET, this is on G2E. Those are backup files on Windows. The tilde here is backup file on Unix. Who needs backup file? If you're trying to get a backup file, it means you're trying to get the raw file. You're attacking me, and I can detect it. My absolute favorite is the booby trap. It works on any kind of warfare, whether military or anything else, and it always works. It's always the carrots there, and the guy get the carrot and fall. The mouse trap. Example: any decent attacker will look at the source of a page before attacking. And when an attacker sees this, he sees red. All of a sudden, he says, "Man, this application developer is stupid. he forgot to remove the backdoor of his admin. Don't tell me the application developer is so stupid to have this, and if I remove it, I become admin. This is what the attacker will think. So straight away, he will remove the comment, and he will run it, hoping to get admin, thinking that the application developer is an idiot. As soon as he does this, we know he attacks, obviously. A normal user never look at the source code. Do you look at the source code of application? I mean, of HTML pages? You have something else better to do most of the time. And you can create as many booby traps as you want. Classic one, imagine the guy is not logged on yet, and you know your administrator is called Fabrice, for example. If the guy tried to type admin, obviously he doesn't know the admin is called Fabrice. Obviously he's not my user. Obviously I don't want to entertain him. Now imagine you're logged on as Joe, and you try to change your URL to /admin, which is typically where the admin functionality is. You're cheating again. Who asked you to enter the URL directly? You're supposed to click. So whichever booby trap like this are very easy to put in place, and they are foolproof. They are really foolproof. A normal user will not try to go /admin. If he does, he's trying to fool you. But we have a bunch of other classic injections that you could detect pretty easily. You could detect LDAP injection. This is one of those that people don't really talk about. It can be very fun, especially on systems where they use LDAP for authentication. A lot of old attacks are basically designed using by injecting some carriage return characters that don't get handled properly by the attack. It's the same. Who has a carriage return in his name? Unless it's more than 100 characters long and too big to put on a form, your name stands on one line. So we could detect this kind of things. We could detect as well shell command injection, XPath. You have some excellent talk on XPath last year. And COBOL, don't forget about COBOL. Of course, we can always check for parameters that are not supposed to be there in the first place. Browsers do not add parameters on their own will. They don't have a will. So if you see that you have additional parameters, obviously the guy is trying his luck. You'd be surprised how many times this kind of additional parameter work on an actual application when you attack. You try your luck using one of those and you get admin. It happens all the time. So of course, an attacker will try this. If an attacker tries this, we'll flag him. Role bypass. Let's say I'm logged on as Joe. And in my menu, of course, I have a normal menu. I don't have the administrative menu. And I try to go directly to an administrative kind of function directly by typing the URL. I'm cheating again. Easy to detect. And then if you try to modify any validation that we've put in place for you, any restriction that we've put on you that a normal user would follow, whichever you try to bypass, basically, if we can detect it, we will, and we will flag it as such. So now what's interesting is that we can put a score on each and every of them. Let's say the booby trap one is you put the maximum score. A normal user can never do it you cannot trip on it by mistake. Okay, who pressed on view source by mistake? Nobody. Who pressed on view source, uncomment, there is admin, and then send by mistake? No such thing. Or even better, who install an interactive proxy, configure his browser to go through it, modify the thing by mistake? Yeah, I'm waiting. So basically, whichever method that you can think of that I didn't list here, there's probably some more, but those are classic ones that we always use when we attack applications. You could add them in such a framework if the framework is designed properly enough to be modular, to accept plugins and things like this. So you quickly realize that such a framework would be pretty easy to do. It takes some time to write, but then it would be pretty effective. Whenever you try, if you just trip on something simple, that's it. We cut your account right away. So you can't even try further. Once your account is cut, you can still call the bank or call the government if it's a government application and say, hey, my account was, cut. And then they will investigate. So of course, if you're an attacker, you're not going to call the bank and say, sorry, my account is cut. They will investigate and you will go to jail. So you know better. But at least you will stop attacks pretty easily like this. Input validation, that's the holy grail of any application security. You hear this in so many other application security talks. I will not spend too much time on it. Basically, the goal is to really validate that the input you're getting from the user is really what you expect. If you expect a date, please, by all means, verify it's a date. It's not difficult. We know the rule for dates. There is no 30th of February. Try harder. Things like this, but people don't verify. There's a lot of application when you enter 30th of February and that's it. But this is not an attack, so I don't really care. If you don't verify the 30th February, maybe I can do a buffer overflow on it. Maybe I can do other things. If you don't verify, we can perform all the attack beforehand. In a nutshell, if you do your input validation properly, there is almost nothing we can do to attack your application. Again, this framework is just here to stop you from trying in the first place. Okay? This framework, there is a big caveat. This framework will not fix the problem. It will prevent you from abusing this problem and attack the application, but it will not fix the problem. The problem will still be there. The framework will shield you from it. It won't fix it. So to continue with input validation, you want to verify phone numbers. In most of the countries, there are very strict rules for phone number. The amount of digits, and which digits can it start, and things like this. Sometimes it's even coded by region, the first 2 digits for a particular region, and if it doesn't match with the region of the guy, then you know it's cheating. Things like this. Same goes with zip codes. Same goes for amount. Same goes for absolutely every kind of input. Sometimes you don't have any rule for a particular input, like names. You have very few rules on names. Okay, but you have at least one. You know that there is a character set. Let's say it's a government application when you have, let's say, only Malaysians, for example. So Malaysians, you will have typical Malay names, typical Chinese names, typical Indian names. So you have a few char sets only. So you wouldn't accept other char sets, for example. And if the guy has really a name with a different char set, then you force him to Romanize his name. I give you an example, a Russian guy here, for example, you would force him to use Roman letters instead of Cyrillic. Like this, you can input validate properly. Anyway, if a Russian guy opens an account here, his name on the system will already be Romanized because the backend doesn't support Cyrillic. So you must check absolutely everything. Whatever you can, you do it. So now the advantage of this framework is that you will not have to do the input validation yourself. You will tell the framework what is it that you expect, and the framework will validate it for you. Like this, you have no more excuse. You cannot forget it. The problem with input validation is that people always put some form of input validation, but they always forget some. And guess what? You know, we're paid to find out exactly where they forgot, and this is exactly where we will attack. So, of course, we could already put some basic generic input validation inside this framework. Like we could put amounts are amounts, whatever application you use, an amount is an amount. There's never more than 4 digits in an amount. Most of the time it's 2. Zip code is never more than 8 characters, and so on. So we could create some generic validation objects that you could already use. And then if it's not enough, we could either provide you with callbacks. In other words, the framework will call back your own function to verify. Or we could use object-oriented technology and use inheritance, whereby you would specialize a generic object to verify exactly what you want it to verify. Am I going too fast? I lost everybody. Again, this is pretty simple, but if put all together properly, you will stop attacks. You are not doing it at the moment. Like I said, at the moment, most of the applications do proper input validation when they feel like it, which is very rare, in other words. And when they do, they still let you bang on the door. I don't like people banging on my door. So now, miscellaneous validation. This is where we're going to check for all the interesting attacks, as far as I'm concerned. Whichever attack that involves stealing money, involves perverting the functionality of an application, logic flows, could be verified here. So this is a little bit the problem with this framework, is because the framework has no generic way of doing it for you. So it means, in other words, here we will just provide you with a hook for you to place, a placeholder for you to place all your logic validation. This is here that you will have to check whether it's your account or not, whether the guy is authorized or not. We can't do it for you. I mean, I'm talking about banks here because everybody understands, so that we could almost do it for you. But then, what do we know about government processes? Like example, in Singapore, when you want to buy a car, there's a complex process. You need to get a certificate of entitlement. You need to pay for this first, sign up there then, and if you have all this then, you can get your car. So now such an application maybe could be pivoted to bypass some of the steps, for example. So all of this is not generic. We can't do it for you. So it would have to be done at this layer. Business logic very much depends on the logic of the application. What is the business process? What is the application designed for? Advantage is, of course, we would typically be using object-oriented techniques, so you would have less code to write, but you still have to write some. And this is exactly where the problem will still be. This framework is not going to be magic. As in, it still could be magic because even an experienced attacker may trip on booby traps and things like this. But it may not prevent properly logic flows. Why? Is because you may not know your own logic. You may not know your own business process. This is a classic problem. Most of the developers are just given a blueprint saying, hey, you do this. Okay, it needs to transfer from this account to this account, and that's it. We don't give you more information than that. So developers just do the strict minimum that they are told. Remember this. Developers are lazy. I used to be one, I can tell you. We don't do more, not less, just this. So if you don't tell the developer what is it supposed to be, what's the expected behavior and things like this in very detail, the developer will just do it anyhow. And then, of course, even if you have such a framework, if the guy doesn't bother to put checks in place, the checks are not going to be there. Scoring and calculation. This is very important in an enterprise application. You always want to have segregation of duties. Different people have different strong points. A security administrator, for example, knows nothing about application, but he knows how to take action if there is a problem and things like this. He doesn't know how to code, basically. He knows about attacks, but that's all. An application developer, on the other hand, is supposed at least to know about application security. How good the word would be if that would be the case. But now imagine they know about application security, they wouldn't know how to fine-tune the application security to the particular environment. So the advantage of this scoring system is that we have a clear cut between the application itself and its security and the prevention and action side of the security. In other words, the developer just bothered to create his application securely, and then that's it for him. The scoring part will be taken care of by the security administrator. He will be the one who decides, okay, for this attack I give this score, for this attack I give this score, and if you have more than this score, then I send an email. If you have more than this score and you come from a dodgy country, for example, then I call the police. If you come from that country, for example, I don't bother. Like if the attack comes from Korea, I don't even want to bother, because no point. You can call the Korean authority and they won't even listen to you. They have too many attacks. It's not their fault. They are being used as a stepping stone. So they receive so many complaints that when you have an attack from Korea, you might as well just drop it. No need to take action on it. So in other words, it's really the security administrator that will decide the flow of the detection and action. Very important. Like this, everybody do what they know best. Obviously, we have to log and report. This is something most of the applications are not doing properly. I'm sick and tired of doing application security, asking after 3 days for the log of the application, and the developer tell me, here you go, and I have a file of, I don't know, 512 bytes, 2 lines of logs, after, I don't know, 50 successful attacks, after I've already stolen money, after I already crashed the database server twice, no logs, none. Or the other way around, with all the same attacks, I have 10 million entries, with half of them being syntax error from the application when you use it normally. Remember this, when you write an application, check yourself for the error log as a developer. If you already see errors inside this log when there is a normal user using it, it means you made a mistake. Please fix it before we come. There will be less noise like this on the log file. The way an application should log is very simple. Now you won't have to pay attention to it. The framework will take care of you. Will take care of it for you. It's very simple. To the sysadmin, to the server side, you're supposed to log everything in detail, so that, and I mean detail, most of them always forget the IP address or the user who did it. How can I take action? I need all this information. So you log in detail on server side, and of course to the client, you tell him nothing. You just tell him, sorry dude, try again later. And if the guy keep on getting this message, of course he will call your organization and find out what's wrong, and then you can look into it. But you don't want to tell your user, oh, there was an SQL problem right here. In which case, of course, the attacker will be delighted to have all this information, and he will just attack the hell out of you. So the problem of this framework is very simple. The bottom line is still the developer. So I'm telling you, if your developers don't know how to develop, there is nothing we can do for you. This framework will help, but if you choose to bypass it or if you choose to use it poorly, then there's so much we can do to help you. This is really designed to be at that kind of level, very low, so that anybody could use it. The problem is if the level is not even there, it's below, then there's nothing I can do. You'd be surprised how many developers are right there. Of course, the developer will have to use it willingly. After this, you always have the problem of the developer who say, oh, I don't want to use the framework, it's boring, I don't want to use it. And they're very moody people, developers. I used to be, so again, trust me on that one. So if they don't want to use it, then there's nothing you can do for it. There's nothing I can do. Of course, this is a trivial one, but if your application wasn't written using this framework, then this framework can't help. Then you will only be left with the network application prevention system, which, as I told you, is too generic and can't find no attack. Of course, the applications still have to be written more or less properly if they are not even working in the first place, like half of the banking applications out there. Banking applications out there are not working, by the way, most of the time. Even though they go through a quality assessment round of 2 months, we still find regular bugs. As far as I'm concerned, a security bug, security flaw is a bug, nothing more. So they should be fixed, full stop. Another problem of this framework is, of course, flash forms. We cannot record the form on the way out, so on the way back we can't verify. So we could still prevent other kind of attacks, but half of them we wouldn't be able to prevent. We have a problem as well with remoting all the JSON RPC, Ajax, all the Web.2, like people 2.0, like people call it now. And of course, whichever protocol that are not even HTTP based. Of course, the framework could be done in a modular manner, modular enough that it would care for those protocols. But this is the future. Of course, the framework would have to integrate nicely within the standards. So on Java, you already have loads and loads and loads of frameworks. Don't ask me which one is better. To me, all of them have advantages and inconvenience. And again, I don't develop a web application. It's so boring to write. I prefer to break them. It's a lot more fun and faster. .NET, you already have something in there, but it definitely needs to be enhanced. It's very limited right now, the .NET validator mechanism. Of course, if you're not using either .NET or J2E, I think you're making a mistake. You should use one of those two. But if you're not, you would have to do the integration yourself. We're not going to do it for you. Not at this stage, at least. I wouldn't say that this is a caveat. I made a mistake when I did the slides. This is mostly an advantage, at least of the application-based or host-based application intrusion prevention system, is that it will have very few false alarms. This is mostly true for the false alarms is mostly true for the network-based one. Like I said, because we are generic, we will have false alarm. There will be some normal usage that look a bit dodgy but are not. and we will flag them as attacks. On the other hand, for the application-based one, the framework one, this one is pretty straightforward. It depends how well are the constraints defined by the application developer. Again, if the application developer did not define the constraints properly, it becomes your problem as the user, as the guy who ordered this application. When you order an application, make sure you give them detail of exactly how you want it. If you don't, they will do the strict minimum. And any enhancement that you want, they will charge you for it, of course. This is business. If you get false alarms with either the network-based AIPS or the host-based one, you would have to tune the scoring system properly. Let's say you have a lot of people with massive family names, then you would have to tune the scoring system to put the maximum length higher, so that it doesn't trigger so often, and things like this. The main problem of this framework is that it's not implemented yet. The whole goal of those talks in the last 2 or 3 security conferences is to get volunteers. So I'll be available outside, people who are interested in it, hopefully people who can code. If you can code, there is a lot of other things that can be done, like design, documentation, and everything. But for coding, yeah, we will be strict. We have to. I can't be publicizing everywhere that application developers can develop if ourselves we can't. That wouldn't look good. So we will screen the development part. But at least there's everything else, all the design, everything. We need volunteers. Why do I need volunteers? Because this is not going to be commercial. This is going to be most probably, confirmed, it's going to be open source, so that both corporations, governments, everybody who writes serious application could potentially use it. Most probably it's going to be J2EE based, not .NET based, unless Microsoft offer me a license and the other developers a license for .NET and Win2K7 2003 and the support and everything else that you need when you're on Microsoft. I'm not going to pay for that. So, and I don't pirate, so eventually it will be J2EE, unless again Microsoft make a movement. So in conclusion, I'll finish a little bit in advance, so you guys can have a little session for questions, hopefully. Right now there's a gaping hole in the security mechanisms that we have, whether they are preventive, detective, or corrective. Nobody take care of the application side. You have detective controls, corrective control, preventive controls in everything else, in physical security, network security, everything. But application right now, you're not doing it. Can't be blamed. I mean, the market is very, very young. Just started, people started to bother about application only 3 years ago or so. Network security has been there since 1999. Even before, but 1999 was really the peak where everybody got hacked using poor firewalls, going through poor firewalls. Now there's no such thing as a poor firewall. There's a poor firewall administrator. Oh yeah, there's a lot. But poor firewall is very rare. No, but in the past, firewalls were so bad, you send them crafted packet and the firewall would die. No such thing. Because now it's magic, they test it before they release it. Before they didn't. So, it's very young. It will take time before it's mature. Like I say, for example, this talk and other talks are, most of the time at the moment, are just talks. Some have demos and everything, but they're just demos. They are not finished products and everything. And once it's matured, it will take time to be robust. Firewall at the moment are robust. I use firewall because everybody knows what it is. Everybody has one. But it is robust already. Network security is really mature. You have a lot of professionals who know that stuff. Even on in-house, as in you have some network sysadmin who actually understand how a network works, roughly. I mean, roughly enough to secure it, which is not the case in application at the moment either. So I hope you understand that the method I just proposed is very simple. It's just about detecting outright attack patterns. They are simple ones, but combined together, they are really lethal. As in, we can catch advanced attackers as well as idiot ones. The problem is that it will not be easy to integrate. This framework that is not written yet will take quite a while to write, and when it's written, if it has to be integrated with other framework, it will take some time as well. So in a nutshell, yeah, it's not there yet. So don't be so happy. Yeah, we can protect, not yet. But as I said, what you can do at this point of time is to grab some of these methods that you like, that are simple to implement for you. Just implement some of them right now, hard-code it in your application, and you will see the results. It's very interesting. You will catch application. Right now, you have no idea if people attack you or not. You're not looking at your logs. You have no idea. I'm sure people are knocking at the door all the time. To be honest, you have no idea when you get attacked successfully either. Banks know because the money go missing, and this they usually know. But other organizations have no idea that their applications are getting used to do stuff they're not supposed to do. So my last conclusion is bad in a way for people like me. It will make my job harder to do. Whatever I usually try is already written here. So it means whatever I usually try, the basic attack will not work. I will have to attack directly those hardcore ones. Unless, of course, because otherwise you will cut my account right away. And it's bad, but I would say it's good, is that all those crappy automated application assessment tools that already don't work today will work even less tomorrow with this framework. Why? It's because those automated application testing tools, they are just tools. They don't have any intelligence. They don't know that, for example, before you can perform transaction B, you have to do transaction A first. They don't know there is a flow. How could they know? They are just applications. Those, don't get me wrong, those automated application tools can be great when used by professionals, as in from professional application testers. Then yeah, they can use it to go faster and go more in depth. But that's all. So, but at least with this framework now, because all the automated tools do basically the simple attacks I've shown you earlier on, we can catch it very easily and stop them right away. But the best advantage of this is that there will be a natural selection of who can successfully attack and who cannot anymore. Right now it's pretty trivial to attack an application. Of course, a good attacker will perform more, but a Mickey Mouse attacker can already perform a little bit and be very happy about it. Soon he won't be able to perform anything. His account will get cut right away, and only the good one will survive. I'm all for natural selection in every job now. So now we have about 3 minutes to be accurate. We want to be on time. We have 3 minutes for questions. I hope I didn't scare you too much. Yes?
Can you talk about J2EE?
Hello. Yes, you talk about .NET and J2EE. Now, I'm concerned because what about the selection of OS?
.NET, sorry, J2EE run on every OS.
No, sorry, I think I have to rephrase that. Okay, just say I do J2EE. Now, will my host 8 be different if I deploy it on Windows?
No, because it's application based. So let's say, imagine this framework, I write it for J2EE, it will run on any J2EE platform. Now imagine I write the tool for .NET, it will run on any .NET platform, which at the moment is only Microsoft. But it's basically, the host-based one will be written in the same framework that you're using if you want to integrate it like this. So there won't be issue with operating systems. So like I said, typically this one most probably will be implemented in J2EE, in which case it will run on any J2EE application servers. So it will run on Windows, Unix, Solaris, all those guys.
Will the weaknesses of the OS undermine your framework?
No, always. But there is nothing you can do with it. If the guy managed to attack through the network and, for example, shut down your application server, there's nothing my framework can do against this. I'm at a higher level. If the guy go low level and attack or patch the application server, there's nothing I can do. This can only stop application attacks.
Thank you.
Questions over there?
Are there any plans for web services? And what are the overheads?
Web services, those are the remoting technology I mentioned earlier on. The problem we have with those is because there is nothing that goes out to the client. as in nothing that we could parse and understand as an application. We have a problem to know what were the constraints in the first place. Now, of course, that's for the network AIDS. Now for the host one, because the application is the one that decides what goes and what comes back, you could potentially check it. It's based on the application, so whatever communication protocol you use will come back to the application, right? So it means I will have a hand on it.
Do you have any indication on overheads that this would have?
Overhead, that's a classic question, I would say. Right now your overhead is the poor programming. That's your overhead at the moment, most of the time. In other words, the application at the moment are written really, really poorly, and that's why they run on E10Ks, some massive servers instead of running on a Pentium. Java can be very, very fast. People always say Java is slow. It's not. I would give you about 10% overhead.
Do you have
off the top of my head?
Yeah, sorry. Do you have a URL where we could look at a preliminary design?
Right now, no. These are only the slides. But there is a few security speakers, even in this conference right now. You should go and see Meder talk. Although this time he doesn't talk about something similar, but he talks about attacks. So that's pretty related. Whatever he attacks, we want to detect. So you have to see his talk, the last one on the last day. And right now, we're just still talking about it. But very shortly, right now, we didn't have time. There was conference after conference. But as soon as we get time, we'll probably put a page on OWASP.org. This is where most of the application security is happening. So we need to talk to the guys of OWASP and see whether they can spare us a page for this project. Does this answer your question?